Welcome back, Physics 11, to another exciting episode of Mr. Wellsby Gives You Some Notes. In today's lesson, we are going to be going over the big three equations. So, whether you know it or not, this is one of the most exciting lessons of your Physics 11 career. This is going to be the day that at the end of the year you look back and you say, this is the day that I really started to become a physicist. So we're going to be talking about motion and introducing the idea of kinematics. Kinematics is the study of motion. And today we're going to be introducing the three formulas that you're going to be using for the rest of your physics career. So a few points to start out with. When we're talking about an object that's accelerating, then this formula here, v equals the change in displacement divided by time, this gives us only the average velocity. So what I mean by that is, let's say I have a graph like this, and I'm starting out at 0 meters per second, or sorry, this distance. So starting at 0 meters, and I end at 100 meters, and this took 10 seconds. Well, I know on average I was going 10 meters per second, but that's all I really know. I know that in total I went 100 meters, and in total I took 10 seconds to get there. So on average, I'm doing 10 meters per second. Another way of us finding out the average velocity is with this formula here, of course. The average velocity is equal to our initial velocity plus our final velocity divided by 2. Keep in mind, both of these are only with constant acceleration, but in grade 11, that's all the types of problems I'm going to really give you. It's going to be constant acceleration. But what if we want to know a bit more? What if I want to know about the initial velocity or the final velocity? So we do have three formulas that we're going to introduce you to today that will give you a more full picture of how that object moved, or in other words, the kinematics of that object. So for these three formulas, we are going to use these five variables. So v is our final velocity. This is our initial velocity, v naught. And of course, this is acceleration, displacement, and time. Okay, so these are our five variables that we're going to be using for all of these formulas. So let's introduce formula number one. So this formula, v equals v naught plus at. So what this is saying is our final speed depends on our initial speed plus how much acceleration we have and how long we've been accelerating for. So if we've been accelerating for a long time, then obviously that's going to have a bigger impact on our final velocity. So I'm not going to get you to try these problems right now. I'm going to get you to try them after we've written down all three. And you'll notice here that this formula is missing the d. So it doesn't have a d in this particular formula. It has the other four. Let's take a look at this one over here. The next one is displacement equals my initial velocity times time plus 1/2 of my acceleration times my time squared. Now on the video, I'm not going to show you a derivation of how this formula comes about, but I will show you that in class. But nonetheless, for now, this is a formula that you should know. And you may notice that the final velocity is missing in this case here. And lastly, we've got formula number three. And this one is the final velocity squared is equal to the initial velocity squared plus 2 times a times d. Or we can just write that as plus 2ad. Okay, and this formula here, I'm not going to show you the derivation for this one, but it does come from ideas of conservation of energy. So we'll go into that when we get to energy much later in the year. So let's take a look at the first example here. In this case here, we've got a police car traveling at 7 meters per second, speeding up to 22 meters per second in a total of 1.7 seconds. So what is that acceleration? Well, if you want to take a pause here, try this problem out for yourself, and then I'll come back and we'll solve that. And in fact, if you want to pause the video and try all three, and come back when you've done attempting all three. Okay, so hopefully you've tried out the problems. Let's take a look and see if we can solve this. So this is our initial formula. So what I'm going to do, I'm going to skip the drawing in this case here, but if I did want to, just a little car starting with a speed of 7 and then later on going at a speed of 22. I guess I did do a drawing. There you go. And the total time is going to be 1.7 seconds. So if I'm writing down my information, the V naught in this case is given. This is the 7 meters per second. The final speed is going to be 22 meters per second. And I know my time is equal to 1.7 seconds, and the question's asking me for acceleration. So you'll notice it doesn't tell me anything about the distance, but I actually don't need to have the distance in order to solve this problem, as long as I use equation number 1. So if I'm trying to solve for A, let's rearrange the equations. I know the formula is V equals V naught plus AT. I'm going to subtract V naught from both sides, and I'm going to divide both sides by T. And I have A equals V minus V naught over T. Well, wait a second, this should be familiar with to you. This is the acceleration formula that we used in class, our delta V over T, V final minus V initial divided by T. And now we're just plugging in the numbers, and so we have 22 minus 7 divided by 1.7. Plug that in your calculator, and you should get 8.8 meters per second squared. Okay, I'm sure you've done the second one as well, so let's try this one out. Let's see what we know first of all. So I'm not too worried about the drawing, but we have a sprinter who is traveling 100 meters south in 9.61 seconds. What is their acceleration? So let's go over our variables. V naught, do we know that? Well, the number isn't given in the question, but we still do know what our V naught is. And this is where you have to be careful to read the question carefully, because what it says is that he starts from rest. Now, from rest means that my initial speed is 0. And I know that he's going to be accelerating, or she, don't know. Oh no, he is traveling 100 meters south. So my distance is going to be 100 meters. I'm not too worried about the south for negative in this case. That's totally fine. And T is going to be 9.69 seconds. And we're trying to find out what the A is in this case. Well, how are we going to solve this? We're going to use this formula up above. We don't know the final speed, but actually we don't really need the final speed. So let's look at our formula. We have D equals V naught T plus 1/2 AT squared. Now, you may notice that V naught is 0. Well, if V naught is 0, what happens to this term in the equation here? This just goes to 0. So 0 times T, 0 times anything is going to be 0. So this allows us to simplify it. If it didn't allow us to simplify it, we could still solve this. It would just get a bit more messy in terms of rearranging our variables. Another option, another thing that I want to point out is that I'm absolutely fine either way if you put in the numbers and then rearrange the equation, or if you rearrange the equation in terms of the variables and then put in the numbers. There are definitely times when both options are easier. But I will say, as you advance further into your academic career, if you go to university, there are a lot of times where numbers aren't really a part of the situation. So it's good to be able to do both. Now, if the V naught was not 0, I would probably start putting in the numbers first and then kind of simplifying and rearranging, multiplying the V naught and the T together to rearrange it. But in this case here, because V naught's canceled, it should be straightforward enough. So now I have D equals 1/2 AT squared. I'm going to multiply both sides by 2. And I have 2D equals AT squared. And I'm going to divide both sides by T squared. And so I have A equals 2D over T squared. A equals 2D over T squared, which is going to be 2 times 100 divided by 9.69 squared, and that will be 2.13 meters per second squared. So there we go. All right, now let's take a look at problem number 3. So let's see what variables we know and what variables we don't have. Well, first of all, you'll notice something when we come across this problem, or across this question, there's immediately a bit of a problem. It has it in 15 in kilometers per hour and kilometers per hour. So what I would say when you're working on tests or working on any of these physics problems, I would immediately make those changes to any units that aren't in meters or seconds or uh, kilograms, etc. I would immediately make those changes before you even continue. So I'm just going to take a little detour here. Now we can go through this whole option of, actually let's do the one option with our proper conversion technique. So in this case here, we've got 15.0 kilometers per hour. And I'm going to convert that into meters per second. So I'm going to cancel out my kilometers, and I know there's 1 kilometer for every 1,000 meters. And I also know that there is 1 hour has 60 minutes, and 1 minute has 60 seconds. And so again, my hours are canceled, my minutes are canceled. I'm left with meters per second, so that's good. So 15 times 1,000 divided by 60 divided by 60 is going to be 4.16 or 4.17 meters per second. 4.16 repeating. Okay, so this is one way of doing it. I will say that I'm fine with you taking the shortcut. So just remember, if you're going from, this is always going to work for you, but if you wanted to convert it the easier way perhaps, or the lazier way, you can do it this way, where you just divide it by 3.6. So 30 kilometers per hour divided by 3.6 gives us 8.3 meters per second. So that's the quick conversion. You can see as what I've done here. 1,000 divided by 60 divided by 60 is the same thing as dividing by 3.6, if you follow through on the math. So here we go. Here's 2 bits of information. Let's see what else we have. So V naught is going to be 4.17. E is 8.3. I also know my acceleration is 2 meters per second squared. And I'm trying to find out what is the distance traveled. Well, let's rearrange our equation here first of all. So I know our equation is v squared equals v naught squared plus 2ad. If I subtract v naught squared from both sides, then I have v squared minus v naught squared equals 2d, and 2ad, and I'm going to divide both sides by 2a, and so I have d equals v squared minus v naught squared over 2a. And I'm left with this calculation. So this is going to be 8.3 squared minus 4.16 or 7 squared divided by 2 times 2. Plug that into my calculator correctly, and I should have 13.0 meters. So that is my total distance traveled for this problem here. All right. So hopefully you followed along with that. Again, if you have any issues with that, of course, feel free to pause the video and replay that and make sure that you understand exactly what's going on. Now for the next 3, I'm not going to go over the full solution for all of these. I'm going to go through the full solution with 1. I'd encourage you to try all of them, but for number 2 and 3, I'm just going to give you the answer, and if you don't get the same answer as me, please do let me know. But try them out now, and then I'll go through the solution for number 1 and post the answers for number 2. So pause the video. Okay, so hopefully you have paused the video and you've given this a try. Here we go with the problem. So we've got a truck that's traveling at 16 meters per second. Some event happens. I'm not too concerned with what the event is. So traveling at 16 meters per second, it hits the jets and accelerates at 14 meters per second squared for 3.25 seconds. So I've got this truck moving along, and it's initially going 16, and then it hits the booster and goes up at 14 meters per second squared, and that's going to be for 3.25 seconds. And so let's take a look here. This is our drawing. We've just got a rocket car that's getting faster. So not the most important drawing, but let's see what we have for our information. So V naught, what is that going to be? Well, that's our initial speed, which we said was 16 meters per second. Now what about, what else do we know? We know the acceleration is 14.0 meters per second squared. We know the t is equal to 3.25 seconds. We're trying to find, in this case, the final velocity. So this is our question here. So let's see what we have. We have these four variables, one of them being an unknown variable, the final velocity. So what formula do we have that allows us to compare all these four quantities together? Well, there's only one of the big three that's going to work in this case here, and that's going to be v equals v naught plus at. You can see here if we used this one here, we couldn't really do this one because we don't know it. Well, first of all, it doesn't have v in the problem, so, or in the formula, so that's not going to work for us. The other one here, v squared equals v naught squared plus 2ad, well, we can't solve this one either because we don't know v, but we also don't know d. And so just as a rule of thumb, and this is an important point that I want to point out, when you have one formula with two things that are unknown, you can't ever solve that. And let me give you an example of what I mean by that. If I tell you that 12 equals x times y, can you ever solve that equation? No, because you have one equation with only one with two unknowns. So whenever you're trying to solve a problem, you need to use as many formulas as there are unknowns in the problem to solve it. So this one here wouldn't work because we have one formula with two unknowns. But we can use this formula here. And so I'm not going to go through the math with you. The algebra, I'm sure you're capable of doing that. But the final velocity is going to be 61.5 meters per second. And I'm going to add that here on my table over here. And the reason why I'm doing that is because if we look at the next problem here, it's asking you how far does it travel in that time. Well, essentially what that's asking you is, what is the distance? Now at this point, we actually have two options to solve this. So take a look for yourself. These are the three formulas, 1, 2, and 3. Which of these formulas could we use to solve D? So if you answered 2 and 3, you are correct. We obviously can't use a formula 1 to solve for D because there's just no D in the equation. But this one we could solve because now we have V naught T, A, and T again. And this one we could also solve because now we have V and V naught and A. So we've got everything we need to solve with either one of those equations. In this case here, if we use D equals V naught T plus 1/2 AT squared, or if we use v squared equals v naught squared plus 2ad, in either case, we are going to have a value of d equals 126 meters. Either formula is going to give you the same information there. Okay, for question 2, one thing to keep in mind is that you are going to get, you should expect to get, and you will get if you do this problem correctly, you will get a negative value. And in fact, the acceleration is going to be negative 75 meters per second squared. And for this one here, you're looking at, so with this one here, I'm not going to go through the whole formula, but I will say when we look at our values that we know, so let's look at the BMW. I'm going to break this into two categories. For BMW, if we look at our variables, V naught is given. Again, you'll have to convert that into meters per second. But we have V naught. We know that it comes to a stop. So we do know our final velocity. Hopefully you recognize that's going to be 0 if you come to a stop. And then we also have the time that takes to come to a stop as well. And in this case for the BMW, it is 4.05 seconds. But we don't know our distance traveled, and we don't know the acceleration. So if we look at our three formulas, again, I'll write them out one more time. V equals V naught plus AT. D equals V naught T plus 1/2 AT squared, and V squared equals V naught squared plus 2AD. Let's take a look and see if we can solve the distance in one formula. So can we use the first formula to solve distance? Well, no, we certainly can't. There's not even a distance in the formula. Could we use the second formula to solve D? Well, No, again, we have a problem. The problem is that we don't know D, but we also don't know A. So can we solve it in this case? No, we can't, because we have two unknowns. And question 3, or formula 3, is the exact same scenario. We don't know A and we don't know D. So we cannot solve D in one single equation. So hopefully you figured out what you're going to need to do. If we don't know D, and we really can't solve it with any of our formulas here. V naught we can calculate, remember, so we'll have this and this and this. We won't have this, and we really can't solve it in one step. So what do you think that extra step's going to be? Well, the answer is you're going to need to find out A first. Once you know A, then you'll be able to use either one of these two formulas. So I'll leave you with that to think about. I'm not going to go over the work with you, but I will say that we should see a value of 111.2 meters for the BMW, 58.8 meters for the F1, and so the difference will be 53.6 meters. And that's the answer that we're looking for. How much further did the BMW travel? A total of 53.6 meters. So give this a try. If you have any questions, please don't hesitate to ask for help. All the best.